Okay, so guys, I think till now, I think everything is clear to everyone. Any doubt regarding like the yesterday's session, confidence interval, or maybe anything? Okay. Okay, so I think yesterday I give you the along with like some coding thing. I give you the introduction about hypothesis testing. Okay, so what is like hypothesis? What do you mean by a hypothesis? Then how we can perform the hypothesis testing. Okay, so I think this is what we have discussed in yesterday's session. Fine. And then at last, I told you like something about confidence interval. Okay, now confidence interval means what? So I told you that this is nothing but an estimator. Okay, so suppose someone reaches to us as assuming as that we are a very good statistician. So now it's our job to help him to make a very good recommendation for like for him, so that he or she will be in profit. Okay, so we need to like give we need to maybe sometimes we need to construct a like kind of an interval with a 95% or maybe a 99% of confidence. Okay, and I think yesterday itself I told you that what is the difference between a G test, T test, and a chi-square test. Okay, let me check whether I told this thing or not. Oh, I think we didn't discuss the difference between a G test, T test, and chi-square. No? Okay, fine. Wait, guys. I will tell you the difference, and then I will give you the walkthrough of the example for a confidence interval. Okay, that how we can construct a confidence interval. Okay. So now, guys, there are like three kind of a test, and even there are more, but like for a time being, we can discuss because even there is one more test which is quite useful one, ANOVA, but the calculation for ANOVA is little bit like a larger. Okay, not harder one, but it is like it is a little bit a time consuming. Okay, so even if you try to solve one question by like with scratch step by step, so it will take around maybe a 30 minutes of time. Okay, so yeah, but yeah, I will give you like kind of a scenario that in which scenario you can use ANOVA. Okay, now, so guys, whenever, okay, so just try to here just try to understand between a G test, T test, and chi-square. Okay, so in what kind of a question we should use a G test, in what kind of a question we should use a T test, and then in what kind of a question we should use a chi-square test. Okay, so whenever we are trying to we are trying to check a significant difference. Okay, as I told you that with the help of hypothesis testing, we are trying to check the credibility of our statement regarding the with respect to inferential statistics. Okay, I think we already discussed this thing. Okay, now if we are saying, if you are like making any kind of a conclusion or a decision based on a sample data, and we are making an inference for the population, so it means there is we need to consider two things, a sample and a population. Okay, so whenever we are trying to check the significant difference between a sample mean and population means in your question, whenever we are trying to take into the consideration a sample mean and a population mean, so whenever we are talking about a sample mean versus a population mean, you can say, okay, whenever we are trying to check whether there is any a significant difference between a sample mean and a population mean, so kya koi difference hai, at that point of a time we can use a G test. Okay, so when we are taking this mean into the consideration, okay, just think that whenever we are trying to take this mean into the consideration, then at that point of a time we can use Z test or a T test. Okay, now fine, so how we are identify, how we can identify, and whenever we are trying to check the significant difference between a sample of variance and the population variance. Okay, population variance. So at that point for time, we will consider a chi-square test. Okay, we can consider chi-square test, and chi-square test is represented by this symbol. Okay, so chi-square test. Now guys, so whenever we are trying to like consider this variance, so it will be a chi-square test, and whenever we are trying to consider this mean, so it will be a g test or t test. Okay, now just try to understand the difference between a g test and t test. So whenever the sample size is lesser than a 30, okay, so whenever the sample size is just n denotes the sample size. Okay, so whenever the sample size is lesser than 30, then it will be a t test, and if the sample size is greater than 30, then it will always be a g test. Okay, so I think now the only one step is remaining, where we need to understand that which test we need to apply on the question given. So I think now you are able to identify that, yeah, which test we need to apply based on the question given. Okay guys, this is clear to everyone? Fine. Okay, this concept is clear to everyone, and everyone of you is able to identify g test, t test, and chi-square test. Fine. Now, so before go into the before solving before solving a question based on a hypothesis testing. Okay guys, so just try to understand that before solving the question based on a hypothesis testing, I will tell you, so I will tell you that how we can construct a confidence interval first. Okay, so I will tell you first that how we can construct a confidence interval, means how we can give a maybe a estimation to someone based on the data given. Okay, so the formula for confidence interval is what? Okay, so I think yesterday also we discussed this formula, but I didn't written the formula, I just written the name. Okay, so confidence interval is going to be nothing but a point estimation or point estimate plus minus margin of error. And I think guys, every one of you is like right now, so I think now every one of you is able to understand that what is point estimate and what is margin of error. Okay, so what is point estimate? So point estimate is nothing but x bar plus minus z alpha upon 2. So this alpha is nothing but a level of significance, sigma upon sigma over under root n. Now this whole thing is called a standard error. Standard error. Okay guys, so sigma is nothing but standard deviation, and n is nothing but a sample size, and z alpha upon 2, it means we are going to take we are going to see the z table, and this alpha is nothing but a level of significance. Okay, so whatever the value of alpha means, whatever the level of significance, we are going to divide that level of significance by 2. Okay, so this is how we can construct a confidence interval. Fine, this is a way we can construct a confidence interval, whether whether we are trying to solve a question for a g test or whether we are trying to solve a question with a t test. In both the way, this is how we can construct a confidence interval. So in case of a t test, so suppose if the, so we always trying to build this confidence interval mainly in mostly in a g test and t test. Okay, so if the sample size is maybe greater than 30, so at that point of time there will be at this position you will use a z, and if the sample size is lesser than 30, then at this point of time you can use t. Okay, and the table is different for both the g and z table. Okay, so I think I already shared the book with you, so even you can go through that book, and you can see that that table. Okay, even I will show you that even online z table and online t table, everything is available. Okay, so even I will share you the link. Now what is the upper bound of this confidence interval? Okay, so I think upper bound for this confidence interval is going to be nothing but x bar plus z alpha upon 2 sigma over root n. Now what is lower bound? Oh guys, यहाँ पे मेरा थोड़ा सा ये okay. So lower bound is going to be 2 sigma over root. Okay, so this is the upper bound and this is the lower bound. Fine. Now just I will take just one question on this because we need to solve like more question and on a hypothesis testing. So I will take question on this and then we'll move on to the question. Here I will take one question and I will show you that statistics book. Okay, now see guys, so just try to read the question. Okay, so a survey was taken of US companies that do business with firms in India. The questions on the survey was approximately how many years. Okay, so this is like one of the question for responses. Okay, so guys just note down the sample size. Okay, so here the sample size is 44. Okay, so a random sample of 44 responses one second. A sample of 44 responses to this question yielded a mean of 10.455 years. Suppose the population standard deviation for this question is 7.7 years. Using this information, construct a 90% confidence interval for the mean number of years that a company has been trading in India for the population of US companies trading with firms in India. Okay, so now guys, यहाँ पे like it is clearly written that we need to construct a 90% confidence interval. Okay, so 90%, it means it is not 95%. They have like a 10% margin of error. So we need to construct a 90% confidence interval for the mean number of years that company has been trading in India. Okay, and for the population of US companies trading with firms in India. Okay, so we need to give our estimation. We need to give our estimation with a 90% confidence. Okay, this is what they're asking to us. Okay, and I think every value is given. Okay, every value is given. So if guys, so just try to understand like this thing from here. So if my okay, so my n is 44, it means we need to perform the G test. My mean is, okay, so my mean is nothing but my x bar is 10.455. Fine. My standard deviation sigma is nothing but 7.7. And my alpha is what? So if my confidence interval is 90%, it means my alpha is what? My alpha is like it is 0.10. Okay, so it is nothing but a 0.10 because 1 minus 90%. 1 minus 90% is going to be what? 0.1. Fine. So this is my alpha level of significance. Fine. Now how I can construct a confidence interval? So this is a formula to construct a confidence interval. So Z alpha upon 2, and then it is going to be a sigma over under root n. Now I have every value, just only I don't have like this information. Okay, so what I need exactly, I need to find out. So alpha upon 2 means what? It is going to be a 0 upon 1 divided by 2. It is going to be a 0.05. It means what? We need to find out Z 0.05. Okay, and if I get this value, so I can easily construct a confidence interval. Now guys, just along with me, I will give you the link also. Along with me, just try to understand that how we can calculate the value from the G table. Okay, so I will share my Chrome screen with you. 1 second. Okay, so here I am having a G table. So even if you want, you can open this site, statistics how to. So here you will get like a G table value. Even I will share this link with all of you in a chat box. Guys, I am not solving a question based on a hypothesis testing. So this is not a question from a hypothesis testing. Okay, and that is why you can't see even I didn't take a null and alternate hypothesis. Okay, so here every time you need to find out alpha upon 2, because here we are trying to find out the confidence interval. Okay, here we need to give the estimation. Here we are not trying to check whether the null hypothesis is, we are able to reject the null hypothesis, or whether we are able to accept the null hypothesis. That is the different concept. Okay, so I'm not taking a hypothesis question over here, guys. Okay, I told you earlier also. So this is not a question based on a hypothesis testing. This is here I only need to construct the confidence interval. I only need to give the estimation with 90% confidence interval. Okay, yeah. So just to go on to over here. Okay, and before I think everyone now I shared the link. Okay, now which value I need to find out, guys? So just take like which value I need to find out. So a Z 0.05. Okay, so here it is not written in this way. It should be written in this way, guys. Sorry. So Z this should be written in this way, Z 0.05. Now it can be calculated in this way. So 1 minus 0.05. Now what is 1 minus 0.05, guys? Okay, what is 1 minus 0.05? Okay, so it is, I think, 0.95. Yeah. Okay, so it is 0.95. Now go on to this table. Okay, along with me, just try to search for a 0. Okay, 1 second, I need to close this ads. Okay, so go on to this table and search for 0.95. So on this plane, okay, on this like whole value on this table, just try to find out 0.95. Okay, so just try to search where is 0.95. Okay, so likewise here we are having 0.975. So just try to search where is 0.95. Okay, in this way. So I think you are able to see this red value. Okay, so I will like increase the size. Okay, so just try to like tell me where is 0.95. I think here I'm having 0.95. Yeah. Okay. 0.95 is there. Okay, so yeah, 0.95 is here. Yeah, correct. Fine. Now just try to find out the intersection, guys. Okay, just try to find out the intersection. So for 0.95, okay, we are having a 1.6. Okay, on here we are having a like 1.6 over here. If you can see, so we are having 1.6 over here. So we need to check the intersection. Okay, we need to check the intersection value. So 1.6 over here, and then 0.0 5 over here. Okay, 0.05 over here. Okay, even people are taking guys this value 0.945. Okay, both the values are like equally close, so people are using like this value. So this is what a 0.04. Okay, so 1.6 plus a 0.04 is what? So 1.6. Okay, you can take any of this value, both are correct, no issues. So if you take this value, so 1.6 plus a 0.05 is equals to what? 1.65. Yeah, 1.65. Yeah, correct. So guys, this is what the value for Z 0.05. So 1.6. Fine. Now I think now we have every value. Okay, so we have each and every value. So upper bound is going to be what? So upper bound is going to be what? X bar plus a Z 0.05 into sigma over under root n, and I can now put the value. So the values are nothing but a 10 point. Okay, so let me check what is this value. So a 10.455 and 7.7. Okay, so 10.455 plus this value is 1.64 into this value is what? This value is 7.7 and this value is 44. Now guys, just make this calculation and you are able to get the upper bound, and similarly for lower bound. Okay, guys, calculate it quick. Just open your calculator and give me the value. So this is going to be again a 0.05 sigma over root n. Now this time this value is going to be 10, again 10.455. Everything is same, just we need to put a negative sign over here, and this is going to be under root 44. Now this value. Okay, so give me this value guys and give me this value. What is the value on upper bound? 12.35. Fine. And what is on the lower bound? Yeah. Now what is the value at like this lower bound, for this lower bound? I think you have all the calculation. You only need to put a minus sign in between. 8.55. So I think only two people, like two students giving answer every time. Fine. I don't have any issue, but I want like every one of you should like make your involvement. I don't think that it is like very hard mathematics. Okay, and even I try my best to make you understand in a like simpler way. Okay, so now this is the confidence interval. This is estimate which you can give. This is the estimate which we can give with a 90% confidence, with a 90% confidence. Okay, so guys, this is how you can construct a confidence interval for any kind of a question. Okay, you need to only search for what you only need to search for what I can say. Okay, so you only need to search for a mu and a sigma. Okay, so suppose if it is not given, and suppose like if it may be related to t-test, so suppose as I told you yesterday that as a statistician, and suppose as a shopkeeper of an electronic item, so I'm having I'm having I'm running a I'm running a shop. I'm running an electronic shop, and there I'm having a different gadgets, maybe a laptop, mobile phone, PC, and all. So based on the last year sell, now I'm going to make order for this year. Okay, so suppose last year I make like this kind of an order. So maybe like I give you the data for whole 12 months. So based on like last, so maybe a 30, then a 35, then 36. Then maybe a 34, then 24, 44, and then again 36, then maybe a 50, then maybe a 40. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then maybe 52, then maybe a 48, and then it may be a okay 35. Okay, so guys, maybe this is these are the like mobile phones which I have ordered in the last month. Okay, now based on this I need to construct a confidence interval to and I need to like suggest estimation to the shopkeeper so that he will be in profit. So I think we already have a data set, so we can like find out a mean and a standard deviation. Okay, I can easily find out the mean and standard deviation, and now based on that mean and standard deviation, again I need to like build my confidence interval. So x bar, I can calculate with this value is going to be nothing but, so this time it is going to be alpha upon 2, and maybe I want this confidence to be a 99%. Okay, so alpha upon 2 and then sigma over root n. So T table is having like a different. Okay, so if you go onto the internet and go search for a T table, so you are able to see a different values for the T table. Okay, so for that also we can easily identify. Even identifying the value for T table is like easier in comparison with the Z table. Okay, so suppose here alpha is what? Alpha is what? Alpha is nothing but 0. Okay, so 0.01. Now 0.01 divided by 2. Okay, so even here in T table, so T table is more easy in comparison to G table. Okay, so if I show you the T table, so let's see, this T table is more easy. Okay, so here I'm having like a different for I can say I can go. Yeah, here you can see. Okay, so suppose for like one tel, if you are having maybe a 0.01, so if you divide this value with 2, so it will be yeah, suppose if it is like 0.01, if you divide this value with 2, so maybe it is like 0.05. So here we have something called a degree of freedom. So degree of freedom is equal to nothing but n minus 1. Okay, so n is maybe 12, so n minus 1 is 11. So you need to check for like this 11. Okay, and then you need to like check for like, so alpha is what? Alpha here is maybe a 0.01, and if you divide that 0.01 with 2, so what is that value? So a 0.01 divided by like 2, so it will be a 0.005. Okay, so this value, I think this. So here you need to like search for, so the your value is 3.106. Okay, 3.106. Fine. So even T table table value is like easier in comparison to G table. Okay, so now just come on to this thing again. So here you only need to find out X bar. So you can do this calculation even with the numpy or directly, and then you can try to find out sigma. N is you n already, and you know already, and then you can calculate this thing. Fine. So this is how you can like construct a confidence interval every time. Okay, so this is not a question from a hypothesis testing. This is like I am trying to tell you that how you can construct a confidence interval, means how you can give a proper estimation. Okay, not just not a hypothetical estimation, not a kind of assumption, a proper estimation with some powerful confidence to someone. Okay, so this is how you can like create a proper estimation for like any person, for anyone. Okay, clear to everyone this how you can construct a confidence interval, guys? Any doubt regarding this like a construction of a confidence interval? Okay, now let's take me now let's start with the like calculation of a hypothesis testing. Okay, so before guys starting the questions of hypothesis testing, I want all of you to like go through these steps once. Okay, because I know that you may forget this step if you have not written anywhere. So I want all of you to go through all these 6 and 7 steps once more, because and now we have all the idea. Okay, we know that how we can calculate the level of significance, or what is the level of significance. We know that how we can choose the type of a test. We know that yeah, how we can calculate the test statistic, and even we know that how we can create a critical table, and how like what is a confidence interval. So right now, now we know each and everything. Okay, so I just want you to go through these steps once. Okay, so that you have an idea in your mind that how we can approach towards the question based on a hypothesis testing. Okay, then I will solve a question for you. Okay, so guys, just take 1 minute and go through these steps. Okay, guys. I think, yeah, these steps is clear to everyone. Now, guys, I will give you the questions and just try to understand the question first. Okay, just try to listen the question carefully, because if you're not able to listen the question carefully, you are not able to solve like any question. Okay, so the first question. Okay, so guys, suppose there is like one factory, or sorry, like one manufacturer. Okay, okay, just try to understand in this way. So suppose you are a wholesaler. Okay, so you are a wholesaler and you want to purchase maybe a printer. Okay, so you want to like purchase a printer in a wholesale. Okay, so means you want to purchase like a printer or cartridge in a very huge amount. Okay, so maybe around 5,000 or 10,000 cartridges you want to purchase just in one shot in a wholesale. So you reach to like one a manufacturing factory, like one factory where this kind like a cartridge or printer is like manufactured. Okay, now a manufacturer making this claim. Okay, so a manufacturer of a like printer a cartridge claims that his like cartridge, whatever the cartridge manufactured by like their company or their factory, each cartridge is having a capacity. So on an average, each cartridge is having a capacity of printing at least 500 pages. Okay, so each cartridge is having, on an average, is having a capacity of printing 500 pages, at least 500 pages. Okay, so this is a claim. This is a claim made by the manufacturer. Okay, now if I want to purchase anything, if I want to purchase like those printer into the wholesale, okay, means a huge amount in a bulk, so definitely I want to test his claim, whether his claim is correct or not. Okay, and if his claim is true, if his like whatever the claim he's making, if his claim is true, then I'm going to buy that like printer. I'm going to buy a printer from their factory. And if the claim is not true, if the claim is false, I'm not going to buy a cartridge. Okay, so I think, guys, every one of you is able to understand the condition. Fine. Okay, now, so the population mean over here is what? So the population mean is 500, like at least 500, means 500, or like it is equals to 500 or more than 500. Fine. Now what to test his claim? Okay, so to test his claim, what I am doing, I will take like a sample of maybe 100 cartridges. Okay, a sample of 100 cartridges I have taken, and at a time of testing, I got like some result that on an average, that every printer is able to print like 490 pages plus minus 30. Okay, 490 pages with a standard deviation of 30. Okay, so this is a value I got when I like try to test his claim with the sample of 100 printers. Okay, so guys, I think now the value is clear to everyone. And even if I want to reform or like form this question, so how I can like write this question? So because I want all of you to understand the question first, so I can write a manufacturer of printer cartridge. Okay, so a printer cartridge claims that a certain cartridge manufactured. Okay, so I'm writing in short by him. I will give you the document, and in a document you are able to get the complete question. Don't worry. Has a mean printing capacity, of at least, okay, so at least 500 pages. Fine. So this is a claim. This is a claim made by the manufacturer. Okay, guys. Now a wholesale, okay, so like a purchaser, okay, so as a wholesale purchaser, so a purchaser selects a sample of, so he selects a random sample, so selects a sample of 100 printers, fine. So here the sample size is nothing but 100 and test them. और टेस्ट में क्या मिला, so what is the value he got after the testing? So the mean printing capacity, okay, so I'm just writing in in a short. So the mean capacity, okay, so the mean printing capacity is nothing but come out to be 490 pages with standard deviation, with a standard deviation 30. Okay guys, question is clear to everyone? Okay, so a manufacturer making a claim that his cartridge is having a capacity of printing at least 500 pages. Okay, now a purchaser select a sample of 100 pages, sorry, 100 printers, and at a time of testing he got that 490 pages, that a mean capacity is 490 pages plus minus 30. Okay, now I think if I ask you, so the very first thing, the very first step is what we need to identify null and alternate hypothesis. Okay, so what is a null and alternate hypothesis? So null hypothesis is what? So I can write a complete statement that the claim of the manufacturer, okay, or even I can write in a short that I am going to buy the printer. Okay, because in what condition I am going to buy? I am going to buy only if the claim is correct. Okay, so here I can write this thing in a mathematical way that if the mean printing capacity is greater than or equals to 500, because he claims for at least. Okay, he claims for at least. Okay, so if the mu is greater than or equals to 500, then only I am going to buy the printer. Otherwise, I am not going to buy the printer. Okay, so otherwise I am not going to buy the printer, and here mu is lesser than 500. So if the mu is lesser than 500, I am not going to buy the printer. If the mu is greater than or equals to 500, I am going to buy the printer. And now I need to okay, so here the question is, okay, so here I can frame a question that should the purchaser reject the claim of manufacturer? So can I reject, okay, so as a purchaser, can I reject the claim of the manufacturer at the significance level of 5%? Okay, so at the significance level of 5%, it means now my second step is what? I need to identify the significance level. So the significance level is nothing but 5%. Okay, guys. Now I want to ask you one thing. What? So which kind of a test is this? Whether it is one tell or whether it is a two tell test? Okay, whether, so this is the third step. You need to identify whether it is one tell or whether it is a two tell test. Yeah, can anyone tell me whether it is one tell or two tell? Yeah, one tell, correct. Okay, so this is nothing but a one tell test. And on which side, guys? On which side? Yeah, correct, one tell. And on which side? Left hand or right hand side? Yeah, correct, right hand side, correct. You guys are genius. Okay, so this is a one tell test on the right hand side. Fine. So my three steps are clear. Now fourth step. So which kind of a test I can apply over here, guys? So this is, I think we are talking in terms of mean. So I think a G test or T test can be applied. Now whether I am going to take a G test or whether I am going to take a T test. Okay, guys, whether I am going to take a G test or T test. Yeah, correct, G test, correct, because my sample size is greater than 30. It is 100. Okay, so I am going to apply a G test. So fourth, I think we are able to done three till fourth step. Now fifth step is what? I need to calculate the G test. Okay, I need to calculate the test statistic value. So fifth step is what? I need to calculate the test statistic value. Okay, so now what is the formula for G test? So the formula for G test is nothing but sample mean minus population mean. Okay, so sample mean minus population mean divided by standard error. Okay, so this is the formula, guys, for the calculation of G test. Okay, so write down this formula. Now I can denote this thing with this. So x bar minus mu divided by sigma over root n. Okay. Now, guys, just give me the values. I think every value is given over here. So what is the sample mean given? What is the sample mean? I think 490. What is the population mean? 500. Yeah. What is the sample size? 100. And what is a sigma? 30. Okay. So every value is given. Now just put this values over here. So 490 minus 500 divided by sigma means 30 over root n means 100. Okay, guys. So now make this, do this calculation quick. So minus 10 upon I think 3, because 30 upon 10. 30 upon 10 is going to be 3. I think this calculation is pretty simple. Minus 3.33. Yeah, minus 3.33. So now I'm able to do till 5th step. Now come on to the 6th step. Okay, so I need to decide the critical range. Okay, now 6th step is what I need to decide the critical range. So I'm able to get the value for G test. Now I need to calculate the value for a G okay, I need to calculate the value for G statistic, means G at significance level. So what is a G at significance level? So what is my significance level? I think guys 0.05. Okay, because 5% means what? A 0.05. Fine. And here I need to perform only a one tell test, so I'm not going to divide this value. I'm not going to divide this value by 2. Okay, so what is the value at a 0.05? What is the value of Z at 0.05? So I think we already have this value. We already find this value. Okay, what is this value, guys? What is this value? What is the value at Z 0.05? अभी निकाला था. अरे मेरे भाई. So what is the value? What is the value of Z 0.05? This is fine. Now what is the, 1.645, correct? So 1.645, and because I'm okay, so because I'm we are doing sorry, one second, this is not a right hand side test, guys. I think you give me the wrong answer, and I have right, because I'm searching for a mu lesser than 500 na? So this is a left hand side test. Okay, this is not a right hand side test. Yeah, we need to we need to check for the left hand side. Mu is lesser than 500. Okay, so this is a left hand tell test. Yeah, bhai, you didn't found earlier minus 0.95. Okay, let me show you. 0.95 is something else, bhai. Let me show you. Okay, see, 1.64. See, 1.64. This 0.95 is this. 1 minus 0.05. Fine. Okay. So here I'm getting a value as 1.645, but I'm doing a left hand tell test. Okay, as I'm doing a left hand tell test, so this should be a minus. Okay, so we need to apply a minus over here, and I can write in a a bracket that since it is a left tell test. Okay, it is a left tell test. Fine. Now construct a critical reason for this. Okay, now construct a critical reason for this. So how I can construct a critical reason, guys? So just see, and then because in the 7th step we only need to make a decision. Okay, so I need to construct a critical reason. So this is like a normal distribution graph, a bell-shaped curve. Okay, maybe my drawing is not up to mark, so yeah, but it is a normal distribution curve. So here I am having a 0. So on the left hand side, so minus 6.4 minus 1.645 maybe lies somewhere over here. Okay, Fine. So this is guys my critical reason. Okay. So this is my critical reason. Okay. So this is my critical reason. Means a rejection reason. This is my critical reason, and this is my like confidence. Okay, so this is my confidence. This is my confidence reason, or you can say this is my acceptance reason. Okay, and this is my rejection reason. Now, just check that where your Z statistic value lies. Okay, so a Z statistic value is nothing but minus 3.33. So minus 3.33 is going to lie somewhere over here. So it is lying in a critical region. So this value lying in a critical region. So means it is lying in a not in a rejection region, and that is why we are going to reject the null hypothesis, and we are going to accept the null hypothesis. Means the claim which is made by the manufacturer is not true. Okay, it means that whatever the claim made by the manufacturer, the claim is completely false. He is making a wrong claim. His claim is not true at all. Okay, okay, so we are going to reject the null hypothesis, and definitely so yeah, the answer of this question is going to be yes. Okay, so the answer, because the question asked at the end is, should the purchaser reject the claim of the manufacturer? Yes, the claim purchaser can reject the claim of the manufacturer. Okay, because null hypothesis is rejected. Okay, whatever the claim he is making, the claim is rejected, and we are going to accept the null alternate hypothesis. Okay, guys, so this question or this explanation is clear to everyone. Anyone having a doubt regarding this explanation? Okay, and and I think you can understand that I simply follow the steps which I have told you. Okay, I simply follow all those 7 steps. Okay, so this is clear to everyone. Anywhere you are having like any doubt regarding any step or regarding anything, just clear this thing with me right now. Okay, practical example is very interesting, sir. Oh, thank you. So can you go back to when the sample size is lesser than 30, then you can use a t-test. Okay, so here the sample size is more than 30, and that is why we are using a g-test. Okay, I already write this thing earlier. Okay, so can you go back to the question? Yeah, I can go back to the question. Even I will share the document. Okay, so maybe after the today's session itself, I will share the document, so you are able to see all the questions over there. Okay, so this is the question, right? Okay, so you can check the question again if you want to check. Fine. So guys, you want me like to take one more question on G test, or should I proceed? Okay, and answer this question by assuming in your mind that we have a time constant also. Okay, so but yeah, if you want, we can take one more question. Otherwise, I can proceed with the like a next kind of a test. Quick. Sumit, Syed, Rajkumar, all of you guys who are like, I'm okay. I'm trying to remembering the name. Thanks, sir. So yeah, can we take one more question, or shall I like proceed for the next kind of a test? Okay, yeah. Okay, fine. Let me take. Okay, so let me check. Yeah, everything is possible by. Don't worry. Until and unless you are not. Okay, but if I'm taking one more question, so I want that you guys should like solve this like question for me. Okay, then only it will be a useful one. Okay, 1 second. Let me open one. Okay, so I'm sharing like one question which I have got maybe sometimes before. Okay, so 1 second. Let me put this question over here. Okay, so this is the question, by. I think this is like, yeah, everyone is able to see the question. I think yeah. Now, okay, just try to answer this question. Okay, but try to like solve by yourself first, because that is why I took like one more question. So try to solve like, just take like 1 or 2 minutes, and at least try to give me the null alternate hypothesis. These are the things. Okay. Then definitely we can proceed, because if you are able to like give these answers, so definitely I can understand that, yeah, you are able to understand the things. Okay, guys. So okay, so I think the very first step which I need to take is a null and alternate hypothesis. Okay, so the question is, Gordon Beverage Company bottle soft drink with an automatic filling machine. Okay, when the process is running properly. Okay, so whenever like the process is running properly. Okay, so if the process is running properly, then the mean fill is 10 ounces per can. Okay, fine, correct. The machine has a known standard deviation of 0.20 ounces. Each day, company selects a random sample of 36 cans and measures the volume in each can. They then test to determine whether the filling process. Okay, so there is a like a beverage company. So I think yesterday itself I took one example of an straw. So now I think every one of you aware about like a can. Okay, so like okay, so everyone maybe of you using a like can. Okay, so for like cold drink. Okay, so for any kind of a cold drink. Okay, so this is a company who is like produces like that can. Okay, and they are checking that whether their machine is working properly or not. Okay, so if the machine is working properly, so the mean fill is 10 ounce per can. Okay, so in each can they are like filling a 10 ounces, fine. And with the standard deviation is 0.20. Each day they select a random sample of 36 can. Okay, so here the sample size is 36, remember. And then they test to determine whether the filling process is working properly or not, fine. Now, the test is conducted using a 0.05% significance level using the test statistic approach. What the conclusion should company reach if the sample means, okay, so here the sample means 9.95 ounces. Okay, or the null hypothesis be rejected. Okay, so just tell me the null and alternate hypothesis first. Okay, what is null and what is alternate hypothesis? I didn't ask for like what is this minus 1.66. Even I didn't get that what is like this minus 1.66. What is null and alternate hypothesis first? Syed, Sumit, anyone? What is a null hypothesis? Null hypothesis will not be rejected. Okay, but okay, I'm asking you the step and you are giving me the answer straight away. Okay, so the null hypothesis, guys, it means that okay, it may or may not be rejected, but I think I'm asking you the steps. Okay, so guys, if you just giving me the direct answer, so just then stay with your answer right now, because I need to tell like everyone that how they can like approach towards the question. Okay, so the null hypothesis, guys, is null hypothesis means the machine is working properly. Okay, so I can write a machine is working properly. Okay, or even I can directly write, because I think you can make like a better statement. So I can directly write working like properly. Okay. Okay, so Syed and like anyone who is giving me the direct answer, just stop it. Okay, fine. Whatever the question I'm asking, if you can try to answer those questions. Okay, just give me the direct answer. Okay, for now. If I will ask you. Okay, I think you already give the answer that it will be rejected. It will be rejected. Okay, so stay tuned for now. Yeah, filling process is working properly. This is the null hypothesis, correct? Okay, so even I can write working properly. Now, in which condition it will like this is a like working properly when my mu is equals to 10. Fine. Now, alternate hypothesis is what? Not working properly. I can say not working properly, and when it is not working properly, if my mu is not equals to 10. Okay, so this is a null and alternate hypothesis. So first step is completed. Now the second step is I need to decide a level of significance. So level of significance is 0.05. Fine. Now whether it is one tell or two tell test. So I think, guys, this is a two tell test. Okay, this is a two tell test. Okay, so the third step is also completed. And which test statistic I need to apply? So I think I need to apply a G test, because the sample size is greater than 30. Fine. So these four things are clear to everyone. Now just try to calculate the G test value. So the G test value is going to be what? A sample mean. So what is the sample mean, guys? So I think sample mean is 9.95 minus a population mean divided by standard deviation, which is 0.20 divided by under root 36. Okay, so now if you calculate this thing, so it will be 9.95 minus 10 is going to be I think 1 second, let me make this like calculation. So 9.95 minus 10, it is going to 0.05. Okay, so a minus 0.05, then this is going to be 0.20 divided by a 6. Okay, so it is nothing but a 0.03. So the answer will be a minus 1.51. Right? So minus 1.51. No, I think it is minus 1.51. Okay. Let me check also whether maybe it may possible that I am wrong. Okay, so 0.20 divided by 6, it is 0.03. Yeah, correct. Now 0.05 divided by 0.03, it is, oh sorry, yeah, correct, minus 1.66. Sorry guys, yeah, correct, he's correct, minus 1.66. Sorry. Fine. Now I need to okay, so this is like fifth step, which is completed. Now I need to check a G table at 0.05, not at 0.05, because here I'm doing a two tell test, so it will be a 0.05 divided by 2. Okay, it means it will become a 0.025. Now what is the value at 0.025? Okay, so can anyone tell me that what is the value at 0.025, guys? Okay, even I will show you, because I need to make you understand that how you can check check this value. So a 0.025, guys. So 0.025 means, so last time when I am having a 0.05, so I am making this calculation as 1 minus 0.05. Okay, and the answer will be 0.95. So I am checking for 0.95. Now if you try to do this calculation for 0.025, so it will be 1 minus 0.025, and the answer will be 0.975. Okay, 0.975. Okay, now try to check at 0.975. So even it is like written with the red color itself. So the answer for 0.975 is going to be nothing but 1.9, and here I'm having 0.06. So 1.96. Okay, 1.96. So this value is nothing but a 1.96, and I'm doing a two-tail test. It means my critical region will be on both the side. Okay, so my critical region will be on both the side. Okay, so here I'm having my critical region, and here also I'm having my critical region. Okay, so minus 1 point, plus 1.96 and minus 1.96. And guys, just try to check where this one second. Oh, what happened with this? Oh, what happened? It's not like my pen. One second, guys. Oh. Okay, so I'm taking I'm telling this thing orally, that minus 1.51 is lying in the acceptance region, because it will lie somewhere over like here. So if you're able to see my cursor, so it is lying somewhere over here. So it is lying in a acceptance region. It means we are not able to reject the null hypothesis. So the question which is which is asked to you, that should we can reject the null hypothesis. So answer is no, we are not able to reject the null hypothesis. Okay, guys, so this is the correct answer. And okay, fine. So now come on to the next test. But I think I'm having like some problem with this my mouse, and like my system is not working. So guys, wait, I will like reconnect in maybe 1-2 minutes. Okay, wait guys, wait.
Hello, I reached the part.
Hello.
Shivam, you're audible now.
Thank you. Okay. Okay, guys. So I think every one of you is able to like understand that, yeah, how I am able to reject the null hypothesis. Sorry, I'm able to accept the null hypothesis. Okay, and some of you are, yeah, extremely genius, because you already like give this answer in a very short time. Okay, but yeah, I will like construct this thing. I should like construct this thing for like rest of the people. So minus 1.96 and then a plus 1.96. So this is, guys, my critical reason. Okay, so the one maybe who is not able to understand. Okay, and whatever the value I am getting from Z statistics, so that value is nothing but minus 1.51. So it is lying in an acceptance region. This value is not lying in a rejection region. So that is why I am going to accept the null hypothesis, and I am going to reject the null hypothesis. Oh, sorry, yeah, I am going to reject the alternate hypothesis. Okay, so the question which I asked to you, that should I am able to reject the null hypothesis. So the answer will be no, because my test statistic lying in a non-rejection region. So I am not able to reject the null hypothesis. Okay. So guys, anyone having a doubt regarding this explanation? Okay. So I think, yeah, I think every one of you is able to understand this thing, this particular explanation and this particular question. Okay. Yeah, guys, can I get quick yes from your side? Okay, thank you so much, bhai Sumit. Okay, now come on to the next question. Okay. Okay, and guys, even you can tell me. Okay, so if you want like some question for the practice. Okay, so if you go, if you want like some question for the question, so for the practice in form of an assignment. So you can tell me, okay, I will share like one assignment, maybe a 4 or 5 question with you in form of an assignment, and you can try to do that. Okay, even you can get like lot of question in the book which I have shared with you. Okay, now come on to the like a next question. Okay, so 1 second guys, just uh, yeah, wait for a minute. I will post another question over here based on something. Okay, so just try to like find out something like different, because yeah, even the formula and the rest of the thing is going to be the same for a G test and the T test. The formula is going to be the same always. Okay, so always the formula is going to be the same. Always remember this thing. Okay, so the formula is not going to be like change at all. So I will share like one question with you, and just try to find out whether this you are able to solve like this particular question or not. Okay, 1 second. And guys, I think I shared like both the link with you, link of a G table and the link of a T table. So I want all of you to like be with your T table and G table. Sorry, T table. Okay, so that you can get the like value from there. Okay, I need to, I think, increase the size. Okay, guys. One question, confidence interval. We have different formula, right? Why are we not using that here? Yeah, okay, so yeah, confidence interval. Oh, okay, so Sodan Sayyed Ibrahim, okay, so your name is quite good. Okay, fine. So by in confidence interval, what we are trying to get, okay, what you are trying to achieve with the help of confidence interval. Okay, so we are trying to give some estimation. Okay, we are trying to give like a range of estimation to like someone. Fine. In this case, we are testing our hypothesis. Okay, so we are testing our like claim, our statement, assumption. Okay, so both the things are totally different. Okay, so both the things are like totally different. We are making a like we are trying to make a like some estimation. So in with the help of constructing a confidence interval, we are trying to make a like some estimation. And here we are trying to check the claim. Okay, what like a claim and hypothesis made by the anyone. Okay, so both the things are different, so that is why we have a like different formula for like both the things. Okay, now try to understand this question. I think but yeah, I think every one of you is able to understand. Only one thing is going to be differ, rest of the things are going to be the same. But then also I will take like this question so that it will like give you more energy. A tire manufacturer claims that the average life of a particular category of its tire is 18,000 kilometers. Okay, so this is a claim made by the tire manufacturer that the average life of particular category of a tire is 18,000 kilometers. Fine. Now, okay, when used under the normal driving condition, I think so. So the claim is clear to everyone. Okay, so the statement is clear to everyone. Now, a random sample of 16 tires was tested. Okay, so here they are taking a sample of like 16 tires, means the sample size is 16. The mean and standard deviation of life of the tires in the sample were 20,000 and 6,000 kilometers respectively. Okay, so the mean of the mean which they have calculated with this like sample of 16 tires is 20,000 kilometer, and the standard deviation is 6,000 kilometer. Fine. Now each and every value is clear to I think everyone. Fine. Now, assuming that the life of the tire is normally distributed, okay, test the claim of the manufacturer at 1% level of significance. Fine. Okay, no issue. I think this question is very much like clear to everyone. So null hypothesis is what? So null hypothesis is average life of a particular category of its tire is 18,000. Okay, so means the average life of average life of a tire is 18,000. Okay, so I think this is like clear to everyone. Average life of a tire is 18,000 kilometer. It means mu is equals to 18,000 kilometer. Fine. Now, alternate hypothesis is always going to be the opposite of null hypothesis. So the average life of a tire is not 18,000 kilometer. Okay, 18,000 kilometer. Okay, so it means mu should not be equals to 18. Fine. So my first step is completed. Now the second is I need to decide the level of significance. So level of significance is 1%. Okay, so here it is given level of significance is 1%. Fine. Now whether it is one tell or two tell test, guys. So I think this is a two tell test. Yeah, this is a two tell test. Okay, so even the third step is clear to everyone. Now the fourth thing, which test I'm going, which kind of a test I'm going to do, because the sample size is 16. Okay, so it means we are going to do the t test. Okay, someone already given the answer, so yeah, this is going to be a t test. Okay, so 4 steps is completed. Now the fifth step, I need to calculate the t statistic. So what is the formula to calculate the t statistic? Okay, so guys, the formula is same. Okay, the formula is same. Okay, so here also we have a sample size, a sample mean x bar, we have a population mean mu, we have a standard deviation sigma, and we have a sample size Sn. Okay, so the formula is going to be same. Yeah, correct. So x bar is what? What is a sample mean, guys? So I think a sample mean is nothing but a 20,000. Then the population mean is going nothing but 18,000. Then standard deviation is 6,000, and under root this value is 16. Fine. So yeah, guys, just make a quick calculation. So I think this is 2,000. Then a 6,000 into I think 4, because we got maybe 4 from here. So this value is going to be 4 to the 8. I'm correct, or yeah, I think this is correct. So this is going to be 8 upon 6, 1.33. Yeah, thank you guys. 1.33, correct. Now, what is a value at a t? Okay, so if it is a two tell test, it means a 0. Okay, so here alpha is a 1%. It means a 0.01. So now if it is two tell test, so it is going to be a 0.005. Yeah, because 0.1 divided by 2 is what? 0.005. Correct. Now just try to find out a t at 0.005. Okay, so guys, along with me, just try to check the value for a g table. Okay, so open the g table, sorry, t table, not g table. Sorry guys. So open like this g table along with me. Okay, so now 0.005. okay, so I think 0.05 is over here, and this is a degree of freedom, guys. So degree of freedom is equals to n minus 1. Okay, so I think I already told this thing that degree of freedom is n minus 1. So degree of freedom is I think n minus 1. So my n is nothing but 16. So degree of freedom is nothing but 15. Okay, now just in front of 15, try to check what is the value over here. Okay, so I think this value is nothing but 2.947. Okay, guys. Yeah, every one of you like got this value 2.947. Yeah, correct, 2.947, because this is my T 0.05. Okay, and we need to check for a 15 because my degree of freedom is 15. Correct. So my degree of freedom is 15. Okay, so even I will write over here. So degree of freedom df is nothing but n minus 1. Okay, so it will be a 15. Now I am getting a 2.947. Okay, so I think my fifth step is clear. Now a sixth step is I need to draw the critical reason so that we are able to decide whether I need to reject the null hypothesis or whether I need to accept the null hypothesis. Okay, fine. So my like value is a 2.947 and this is a two-tailed test. So I need to check on both hand side. So a 2.947 over here and minus 2.947 over here. Now this is my like critical reason, I can say. Okay, so this is my critical reason. Okay, and here this is my like critical reason, guys. Right. And then what is the value I'm getting from T statistic? It is 1.33. So I think 1.33 will lie over here. Yeah. So this value lies in an acceptance region. It means I am not able to reject the null hypothesis. I need to accept the null hypothesis and I need to reject the alternate hypothesis. Okay, guys, this is clear to everyone? Yeah, null hypothesis accepted. Okay, so this question and explanation is clear to everyone, guys. Anyone having a doubt regarding this thing? No? Okay, so even you can try to do some more question. I will give you like directly like some question based on G and T test, or even you can try to solve a like question by yourself from the book itself. Okay, what like the book which I have given to you, that book is yeah, that book is definitely one of the best book for statistics and probability. So even you can try to solve the question from that book itself. Okay, so yeah, guys, can we proceed? This thing is clear to everyone. Okay, guys, can I get quick yes from your side? Yeah, thank you so much, guys. Okay, now come on to the next kind of a testing. It is called a chi-square test. Chi-square test. And this is denoted by this symbol, chi-square. Fine. Now, in case of a chi-square test, we are going to going to do the question in terms of okay. So fine, I can say that we are going to consider the variance. Okay, so if you I think, guys, what like the three questions which we have solved, in all of like those three questions, we are trying to like take we are trying to check that whether there is any like significant difference between a sample mean and population mean. Okay, so in all the sense, we are trying to check whether there is any a significant difference between a sample mean and a population mean. Fine, I think this is clear to everyone. Now here with the same idea, I am going to check whether there is any significant difference between a sample variance and a population variance. Okay, and guys, here I think from the statistics session, the first session which I have taken, so every one of you know the meaning of or the concept of a variance. Okay, so can anyone tell me like in a quick sense, in quickly, that what do you understand by the variance? Okay, can anyone tell me that what do you understand by the variance? Because we already covered this thing in our statistics session. the first session. So this is the formula to calculate the chi-square test. Guys, anyone? What is a meaning of a variance? Yeah, variance. I think we learned this thing in the very first session. A measure of dispersion. Okay, a kind of a descriptive statistics. Okay, it is a technique in a descriptive statistics, and it comes into the measure of dispersion. Okay, it means we are trying to check the fluctuation from the mean value. Okay, square root of x minus x bar divided by n. Yeah, this is the formula, but the concept is what? The fluctuation from the mean value. Okay, and the fluctuation from the mean value means what? Like a deviation. Okay, so deviation from the mean value means what? We are checking an error. Okay, what error we are making? Okay, how much error we are making? Okay, so a fluctuation from the mean value means what? Okay, so we want like something. Okay, so maybe we want a straw size with maybe this a diameter, but we are fluctuating. Okay, so we are fluctuating with maybe a 2 unit, maybe a 3 unit. So like fluctuation means what? Fluctuation means error. Okay, so how much error we are making? Okay, how much error we are making? How much how much a unit of mistake we are making? Okay, so this is what we call a like variance. This is what we call a fluctuation. Okay, so fluctuation, deviation from the mean value is called a variance. Okay, guys, this concept is clear to everyone. Okay, because without understanding this concept, you are not able to solve like a question based on a chi-square test. So this concept is clear to everyone. Variance is nothing but the amount of error or the amount of fluctuation we are making in like with respect to anything, with respect to like maybe the diameter of a straw, with respect to maybe the length of any rod or anything. Okay. Okay, so this concept is clear to everyone, guys. Please, can I get a quick yes from your side? Okay, thank you so much. Okay, so okay, so now I will take like one question, guys, and then I will explain you that how we can like understand the chi-square test. Okay, and even chi-square test like people are using like chi-square test in for a totally a different purpose, but this is also like one of the thing where we can use a chi-square test. Yeah, note the formula, no issue. N minus 1 dot s square divided by sigma square. Okay, even I will go, I will write, I will definitely write the formula once again. So yeah, right? हो गया, Vinod Kumar, thank you. Okay, guys. So this is a question. This is a question given to us, and now I need to we need to solve this question. Okay, so here I need to find out like a null hypothesis and alternate hypothesis, but be careful because I know that every one of you or like most of you is going to make a mistake in identifying a null and alternate hypothesis. Okay, so even try to identify by yourself and then try to like cross verify with me whether you are able whether you correctly identify the null and alternate hypothesis or not. Okay, so the variance of certain size of towel. Okay, so the variance. Okay, so here we are not talking about a mean. Okay, so the variance And I already told you that variance is nothing but the amount of an error or fluctuation or deviation. Okay. So the variance of a certain size of a towel produced by a machine is 7.2 over a long period of time. Okay. So over a long period of time, there is a company or there may be a factory which is producing a like towel or which is like making a towel, and this is a like a variance they are producing from a very long period of time by at a time of making a towel. Okay, so 7.2 can be any unit. Okay, so it can be a centimeter, it can be a millimeter, it can be a meter. Okay, so any unit like this 7.2, but they are making a mistake, they are making an error or fluctuation of 7.2 over a long period of time. Now a random sample of 20 towels gave a variance of 8. Okay, so now they take a random samples of 20 towels and here they got a variance as 8. Okay, so so the claim is what? The claim is that variance is 7.2. Okay, so the claim is what? The error is 7.2. Okay, so it means it may be like 7.2. Okay, so their claim is they want to be like 7.2 or maybe a lesser than a 7.2, but in a sample we got a variance as 8. Now you need to check if the variability for a towel has increased. Okay, so we need to check, because we need to check whether this claim is correct or not. So we need to check whether the variability of towel has increased at 5% level of significance. So level of significance is given as 5%, assuming a normal distributed sample. Fine, guys. So here, what is a null hypothesis? Okay, so here the null hypothesis. So okay, so people can so in case of a printer. Okay, so if you remember, so just try to relate this question with the first question of a hypothesis testing. So there a manufacturer making a claim that his printer or his cartridge is able to print at least 500 pages. Okay, so because we as a purchaser, we always want a more from the manufacturer. Okay, so we always want a more from a manufacturer, but we never, and manufacturer want to tell a more about his product. Okay, बढ़ा चढ़ा के बताते हैं. But in case of like in this case, this variance means error. Okay, so no one is going to claim that my variance may be high. So he's more happy if the variance is like low. Okay, so he's more happy if the variance is low. So he's making a claim that from a longer period of time, their variance is 7.2. Okay, so null hypothesis is going to be what? So in terms of in mathematical way, so they are making a claim that variance is 7.2. So if it is lesser than 7.2, then also they are happy. Okay, then also they can say yes, my claim is correct. And if the variance is equals to 7.2, then also their claim is correct. Okay, because variance means error. So they are making a claim that we are making a lesser error. We are making a lesser error. Okay. So here the null hypothesis is what? So here the null hypothesis is a variance should be a lesser than or equals to 7.2. And alternate hypothesis is just opposite of this, means the variance should be a greater than 7.2. Okay, guys. So this is my null and alternate hypothesis for this question. Okay. And now the level of significance is given as 5%. And because here we are trying to check for a greater than, okay, right hand side. So this is nothing but a 2-tail test. Okay, sorry, a 1-tail test. Sorry, this is a 1-tail test and a 1-tail test in a right hand side. Okay, so this is a 1-tail test in the right hand side. Fine. So 3 things is clear to everyone, and because we are comparing the variances, a sample variance and a population variance, so we need to apply a chi-square test over here. Okay, now the 5th step is I am going to calculate this chi-square test. Okay, and now I am having every value over here. 7.2 is a null and alternate hypothesis. 7.2 is a null and alternate hypothesis means I'm not able to understand. Okay, so if the value is like lesser than equals to 7.2, it is a null hypothesis. Otherwise, it is a alternate hypothesis. Okay, so the formula for the chi-square is what? The formula for chi-square is n minus 1 s square divided by a sigma square. Okay, so n minus 1 means 20 minus 1, and s square means like we are having a sample variance is what? So the sample variance is nothing but 8. Okay, so sample variance is nothing but 8, and the population variance is nothing but a 7.2. Okay, so S is nothing but a sample variance and sigma is nothing but a population variance, and hence we are already squaring it. Okay, we are already squaring it, and if, even in the question it is written as a variance, it is not written as a standard deviation. Okay, so we are already squaring it. So S square is nothing but, so S is the sample standard deviation and sigma is the population standard deviation. Okay, so I think you all know that variance is nothing but a square of a standard deviation. Okay, so that is why we are getting 8 over here and 7.2 over here. Now, if I calculate, so it is going to be 19 into 8 divided by 7.2. And I think if you make this calculation, so yeah, guys, just give me like the answer for this calculation. 19 into 8 divided by 7.2. Okay, so yeah, quick guys. What is the answer for like this calculation? 20.111. Yeah, I think this is correct. Now I need to check for a like a chi-square at which value. Okay, so hence we are doing a one-tailed test, so we need to check for 0.05. Okay, now open the table for a chi-square. Okay, so just like we have a table for a t test and we have a table for a g test, so similarly we are having a table for a chi-square also. Okay, so just go on to your Google and open the chi-square test table. Okay, so yeah guys, you are able to get you are able to see all the values over here. So we are checking for 0.05 and my degree of freedom is what? Okay, so my sample size is 20, so it means my degree of freedom is nothing but n minus 1, 19. Okay, so sorry, yeah, my sample size is what? Yeah, 20. So I need to check for the 19. Okay, so in front of 19 and in front of a 0.05, what is the value, guys? So I think I'm getting a value as a 30.144. Okay, just check it. 30.144. So 0.05 and then intersection with 19, it is nothing but 30.044. Yes, correct. So come on to this like a paper again. So this value is nothing but a 30 point what a 30 point I think someone written answer in the chat, but 144. Okay guys, so now let's construct a critical reason and then check whether the test statistic value lies in a critical region or whether it is lies in a like acceptance region. Okay, so I think 30.144 is going to like somewhere over here. Okay, and I think this is my like critical reason then. So this is my critical reason then. Okay, and what is the value from the test statistics? That is a 21.11. It means it is lying in a acceptance region. So I am going to accept the null hypothesis and I am going to reject the alternate hypothesis. So it means we are not having a sufficient evidence to reject the null hypothesis. Okay, so it means whatever the claim made by the manufacturer, a manufacturer of a towel, is correct. Okay, so his claim is totally correct. We are not able to reject the null hypothesis. The null hypothesis is correct and the alternate hypothesis is false. Fine, guys. Anyone having any doubt regarding this chi-square test? Why you have not squared it? Okay, so Sultan Sayyid Ibrahim bhai, just tell me the formula for the variance. Okay, what is the variance, bhai? what is a variance? Okay, so what is or just tell me what is the relation between a variance and standard deviation? Okay, can you tell me the relation between variance and standard deviation? Yeah, this thing I can explain again. So yeah, so variance is square, is not, variance is not a square root of standard deviation. By variance is a square of standard deviation. Okay, just go back in your notes and just try to like get this formula again. So variance is always a square of standard deviation. Okay, sigma square. Variance is always a sigma square. Okay, so we already have a sigma square, then how why I am going to like squaring it again? Okay, so in the formula we are having a s square. So s square is nothing but a sample standard deviation, and we are having a sigma square. So sigma square means what? A variance. Fine. Okay, two tell test went to. Okay, so 1 second. Why is it a one tell test? Okay, so okay, I will explain it again. One thing. Okay, come again. Fine. So yeah, okay, so just see the question. Okay, so as I told you that variance means what? Variance means a fluctuation, a error. Okay, a margin, like a unit of an error or the unit of a fluctuation. Okay, so it like variance tells us that how much we are fluctuating from our mean value, or like how much error we are making, how much like total mistakes we are making. Okay, so if we are making any kind of a claim, so suppose when we are making a like claim for the like a capacity of a printer. Okay, so you always make a claim, like suppose if you are making like a claim for any of your product, so you always make a better claim for your product. Okay, you never make a like maybe a lesser kind, you always try to make a better claim or maybe a high-fi claim for your product. Okay, बढ़ा चढ़ा के आप अपने claim को बताओगे with respect to like any product. Fine. So here variance means error. So you always trying to you are always trying to claim for the lesser error. You are never trying to make, you are never trying to claim for the like maybe a big like a bigger error. Okay, so if the value, suppose if after taking a sample, if the error is even lesser than 7.2, then also it's good, na? Then also it's good for them. Yeah, if the error is lesser than 7.2, so whatever the value you are having. Okay, so suppose if after after taking a sample, if you got like lesser value than that, then also it's good. Okay, so suppose if after taking a like variance you got like maybe an error as 7. Okay, so do you are you going to reject the null hypothesis? No, not at all. It's good for me if the if by the time I'm able to reduce the like unit of an error, so it's good for me. Okay, I think it's good, like it's a achievement for of a manufacturer. Okay, so I'm not going to like reject his like null hypothesis. I'm definitely going to buy a towel from him. Okay, because his claim is correct. Even like his variance or whatever the variance he said, it is like it is making a lesser mistake. Okay, so that is why we take a variance is lesser than or equals to 7.2. Okay, and if you are checking for if you check maybe a variance lesser than or equals to like a 7.2, and yeah, so our ultimately my alternate hypothesis is going to be a variance is greater than 7.2. Okay, so it is going to be a one tail test, because we are checking for we are checking to reject the null hypothesis only on the on right hand side, only on one direction. Okay, not on both the sides. Okay, so that is why it is like one tail test, not a two tail test. Okay, so always trying to understand the business problem. Okay, always trying to understand the question with respect to like some business problem. Okay, So it may possible, suppose if you're having like something different like from your domain. Okay, so suppose it is not a kind of a business problem or something, then you can think of, okay, so if the error is maybe a lesser, so if in case of a mean, in case of an average, you can think, okay, so like a straw, so diameter of a straw should not be a very high and it should not be a very less. Okay, so in that scenario, definitely I am going to reject the null hypothesis even if the diameter is like high. Okay, but in this case I'm not. So even suppose like a soap company making a claim that it is their soap is able to clean a 99% of the germs. Okay, so even so, suppose if the soap is able to kill 100% of the germs, then also I'm going to buy that soap because his claim is correct. So we are going to check the null hypothesis greater than or equals to 99%. Even if it is not given in the question, then also I'm going to check for greater than or equals to 99%. I'm not going to check. So I'm not going to reject the null hypothesis. I'm not going to like reject the claim, and I'm not like it is not possible that I'm not going to buy like a soap if the soap is able to clean 100% of the germs. Okay. So this is how we are trying to relate the question. This is how we are trying to relate the question with the business problem, and then we frame our null and alternate hypothesis. Okay. Now this is clear, Meenakshi? Okay, and simple guys, whenever you are having equal to sign in null hypothesis and not equal to sign in alternate hypothesis, so at this point of time you are going to calculate calculate the two-tailed test. Okay, and if you are having maybe a lesser than sign, greater than sign in your null hypothesis and the similar thing in your alternate hypothesis, so you are going to calculate for one-tailed test. Okay, fine. Okay. Now come on to the last topic of today's session. So chi-square. So till now we are doing like whatever the calculation we are doing, we are doing a calculation with respect to a numerical data. Okay. So whatever the hypothesis we are checking or whatever the calculation we are doing with respect to a numerical data. Okay. Now it's time to use a chi-square test for a categorical variable. Okay. So chi-square is like only hypothesis testing which can be used to test the categorical data. So chi-square test for categorical data, or you can say a categorical variables. Okay, and it is also called as a goodness of fit. Goodness of fit test. Okay, and in this kind of a like scenario, guys, in this kind of a scenario, in like terms of a categorical variable, my null and alternate hypothesis is always fixed. Okay, my null and alternate hypothesis is always fixed, and even with respect to a categorical variable, we can also trying to do like one more thing. We can also trying to test like one more thing, which is called a test of independence. Okay, so fine. Even this a test of independence, we can try to see in like at a time of like a machine learning. Okay, so here we can't see like this functionality, but we can like observe this thing, or we can simply use this a chi-square test for the feature selection in a machine learning. Okay, so I know that right now you don't know about a feature selection or machine learning a lot, but in case of we are trying to build a predictive model. Okay, maybe a weather forecasting model or maybe a score prediction model. So any kind of prediction model. So we can use like a chi-square test for the for the feature selection. Okay, so to select the best feature for like modeling. Okay, so that is where we can use this test of independence. But right now we are going to talk about this goodness of fit test. Okay, so yeah, guys, I want you like all of you to like write one like 2 lines of definition for this chi-square test for a categorical variable. Okay, so just write down, guys. The chi-square test. The chi-square test is widely used to estimate the chi-square test is widely used to estimate how closely the distribution of a categorical variable, the chi-square test, is widely used to estimate how closely the distribution of a categorical variables matches an expected distribution. Okay, the chi-square test is widely used to estimate. So this is the first thing. This is what we call the goodness of fit. Okay, in bracket you can try to write down the goodness of fit test. Okay, so the chi-square test is widely used to estimate how closely the distribution of a categorical variable, okay, the distribution of a categorical variable matches an expected distribution. Okay, means here we are trying to check whether the observation is equal to the expectation or not. Okay, so I will explain this thing with an example. And okay, so write down okay, so go ahead and write down or. So second thing, or, so this is what we call a goodness of fit test, or to estimate whether two categorical variables are independent of one another, or whether, or to estimate whether two categorical variables are independent of one another, the test of independence. Okay, so chi-square can be used for two kind of a testing. Okay, one, we can try to test whether a observed value or observed distribution is equal to the expected distribution. So this is what you call the goodness of fit test. And the second thing, we can try to check whether two categorical variables are independent on one another or not. Okay, so independent means there is no dependency of one variable onto the another variable. Okay, so this is what we call test of independence. Okay, so guys, just try to understand this goodness of fit test. Okay, with an example. So suppose there is one survey company. Okay, so there so suppose I think you can take this example of the election itself. Okay, so suppose there is one survey company who is conducting a survey for the election. Okay, and based on their survey, okay, on the based on their survey, they are able to they conduct a survey and they are able to tell you, okay, so this okay, so they conduct a survey and they are able to give the result that this party is going to election this time. Okay, so they are able to give the result, they are able to produce a result that this particular party is going to win the election this time. Okay, fine. Now suppose you are not convinced with this survey. Okay, you are not convinced with this survey. Okay, so the survey company is definitely conduct a survey in on a huge number of people. Okay, means they definitely conduct a survey on a huge number of people. Means I can say that it may be I can consider it as a population. Okay, now maybe I'm not convinced with their survey. Okay, I'm not convinced with their survey with their result. Okay, now so I what I'm trying to do, I can try to conduct my own survey. I can try to conduct my own survey in with maybe some number of people. Okay, so with some number of people means in a sample, I'm trying to conduct my own survey, and then I'm trying to find out the result, and then we are trying to check whether my observed value is equal to the expected value or not. Okay, so here always the null hypothesis is going to be expected is equal to the observed. Okay, so if my observed value is equal to the expected value, so if my if my result is equal to the result produced by that survey company, then it is called a null hypothesis. So this is a null hypothesis, this is a statement of a null hypothesis. And if the both the survey results are different, so it is an alternate hypothesis. Okay, so in this condition, null and alternate hypothesis fixed. Okay, so the statement for the null hypothesis and the statement for the alternate hypothesis is fixed. Okay, guys, understand? So here you can try to write down even null and alternate hypothesis, that the population distribution of the variable is same as the proposed distribution. Okay, so you can try to write down that the population distribution of the variable is same as the proposed distribution. Proposed distribution. Okay. And alternate hypothesis is what? So alternate hypothesis is going to be the distributions are different. The distributions are different. Fine. So this is how you are going to calculate this time. Okay. So chi-square is going to be a summation of observed minus expected. So observed minus expected whole square divided by expected. Okay, guys. So this is how we can calculate whether the observed or the distribution. Okay, so the population distribution is equal to the sample distribution. Okay. So guys, this is how we can like calculate the goodness of fit test, the chi-square test. Okay, so guys, this this calculation is a little bit like longer because even the questions, the form of the question is like different from the question whatever the question we have done till so far. Okay, so the format of the question is little bit different, and even the the calculation is little bit longer. So we are going to like do this calculation in the next session. Okay, because in the next session this is the only calculation which we are going to conduct. The rest of the calculation we have already done. Okay, and then in the next session I'm going to cover like this calculation. So after this calculation I'm going to like talk about one more kind of a testing which is called A/B testing. I will give you not I'm not going to give you the like question, but I'm definitely tell you that what is like ANOVA. Okay, then covariance. Okay, then a Pearson correlation, and then definitely like some like basic thing with a Python. Okay, so some are like basic like analysis, some are like very basic analysis with a Python. Okay, so this is a like thing which we are going to cover in the last session. Okay, guys. So today itself, okay, so not maybe if not possible by tonight, so by tomorrow morning, I will like share the document with you, and in that document you are able to find all these things. Even you are able to find this A/B testing, you are able to find this ANOVA. So maybe you are not able to find this 3 things, but you are able to find like these 2 things over there. Okay, so even you are able to find a like question based on this chi-square. So I will definitely try to share by tonight or maybe tomorrow early morning before like 8 a.m. So you can even go through the question based on this calculation, and even you can try to learn something about A/B testing and A/B testing and even ANOVA. Okay, and then we will discuss, but definitely I'm going to like discuss about this what I can say. Okay, so this the question based on a chi-square goodness of fit, and then I will like discuss, and this is guys, this is a very most important thing. Okay, so this particular topic, this particular concept is very much important. Although the concept is very easy to understand, but this concept is very much important. Okay, so we are going to talk about all this like 5 things in the last session. Okay, so guys, for today's session, anyone having any doubt regarding like today's session? No. And yeah, I can okay, so can I get like something okay, so just can I get like maybe one like yes or no? So do you guys are like enjoying like this 5 days session? Okay, so I think because 4 days are already over, so Do you guys enjoying this session? Are you able to understand like a lot of things more? Okay, so I hope that most of the concepts is like clear. So yeah, are you guys enjoying these sessions? Okay, I just got 1, 2. Yes, okay, fine. Thank you so much. Okay, so thank you so much. Okay. Okay, guys. So this is it for like today's session. And okay, great. So this is like it for today's session, and we are going to like continue in our last session. So in the last session, I'm going to cover all these like 5 topics. Okay, along with like the example based on like the question based on this calculation. Okay, guys. Thank you so much, guys. Ruby ma'am, I think we can
Thank
wrap up
you.
the session.
Yeah. Thank you, Shivam. Am I audible, Shivam?
Yes, ma'am.
Hello. Okay. So today, for today's session, you will be sharing the material, no?
Yes, ma'am.
Okay. Thank you so much. So thank you, Shivam, and thank you all the participants. So kindly join tomorrow for the last day session. Thank you. Kindly end the session, ma'am.